The chapter number system has totally 4 exercises, okay, in which the first exercise what we are going to discuss is only about the numbers, types of numbers available, finding irrational number and rational number in between two given numbers. Okay, it's about finding rational numbers in between given two numbers, whether that could be any rational number or else directly some integer like we may say. Okay, and then this exercise 2 is about representing irrational number on number line. And then exercise 3 is about rational numbers and their decimal expansion fully. Like irrational, rationalization, everything will be discussing in this exercise. And then last exercise, exercise 4, is fully about exponents and powers. So, okay, so what are all the available types of numbers? As you know, we know natural numbers starts from 1 to 1, 2, 3, 4 like up to infinity. Okay, and then whole numbers including 0, and then integers like minus infinity to plus infinity, or including the negative numbers. Okay, that negative number includes the direction, and then there comes a rational number. So rational numbers means we are denoting it like q. Yes. Oh, nobody did, I think. I think we have a network issue. Yes, check with that. Okay, we'll see. And then these rational numbers are denoted as q. Why it is denoted as q, like we have seen earlier? Because that represents quotient of a division. Okay, got it? Any doubts, clarifications? Okay, in this, as we speak of rational numbers, what is the general form of rational number? It is of the form p by q, and that q should not be equal to 0, where this p and q are integers. Okay, so it is to be said that between any two rational numbers, we have, there are how many irrational numbers? Say, how many rational numbers are? Infinite rational numbers, like countless number. Countless numbers of rational numbers. So how do we find such numbers? Okay, so we have several examples. Like in the first example, we see 5 rational numbers between 1 and 2. How will you say 5 rational numbers between 1 and 2? There are two methods. 1 and 2 are rational. So there are two methods. The first method is by taking average. Okay, so we have to find one number in between. This means we have to take average of these two. Okay, then we'll have 3 by 2. Then we may have 1, after that 3 by 2, after that 2. Then again between these two we have to find another such number. How will you figure it out? That is 1 plus 3 by 2 by 2. Then we may have 5 by 4. So 1 and 3 by 2, in between 5 by 4 comes. Likewise, we have to find the 5 numbers. Such a time taking process. But instead of doing this way, we may go with the same denominator. Okay, how will you make it as the same denominator? See, 1 is there and 2 is there. So by 1 like we may consider, and we have to multiply simply 10, not only 10, whatever the number you wish that you can multiply, but I am multiplying 10 so that it would be easier. So we'll be having 10 by 10 and here 20 by 10. Okay, now in between the numbers, how we can say 11 by 10, 12 by 10, 13 by 10 and so on. We have 5 numbers, right? 14 by 10, 15 by 10. So the same procedure we can apply for all the types of questions. For example, 3 and 4. 3 and 4, can you say such numbers? Same way, how we can represent 3 by 1 and 4 by 1. So into 10 by also into 10. So we'll be having 30 by 10, 40 by 10. So we are having 31 by 10, 32 by 10. Okay, likewise. Suppose we have a fraction. Okay, we have a fraction like 3 by 4 and 4 by 5. Then what do? We have to take LCM of these two denominators. Okay, what is LCM of these two denominators? It is 20. Okay, so to make it as 20, we have to multiply 5 on both numerator and denominator. Here to make this denominator as 20, we have to multiply 4 in both numerator and denominator, so that we will be having 15 by 20 and 16 by 20. Okay, now as you can see, this is again continuous number. We can't say 16 by 20, 17 by 20 because it is already there. Between these two we have to find. Will it be sufficient for us? No, it won't. So again what we have to do means, into any other number we can do. Simply 2 also will do. I am doing 10 so that it would be easy. So here also into 10, denominator also into 10. Then what we may get is like 150 by 200, 150 by 200 and 160 by 200. See, 10 numbers we got. What are all the numbers? 151 by 200. That like we can say up to 159. Okay, as many numbers you want we can find. Okay, and then they had a discussion like whether 0 is a rational number or not. Is 0 is a rational number? Is 0 a rational number or not? Yes. Why? Because is 0 a rational number? Can you write it in the form of p by q, where p and q are integers? Of course we can write 0 by q. Q is not equal to 0. Okay, so 0 is a rational number. Okay, and then there are true or false type of question also there. That is, every natural number is a whole number. Is that true or false? And then every integer is a whole number. False. And then every rational number is a whole number. That is also false, because negative numbers are also there. Okay, and then next, this exercise 1.2 is fully based on representing the irrational numbers on the number line. As we can see, the number line we have discussed, right? In the session we discussed, the revision now only I am saying. Number line, what is number line? A straight line in which each points on the line represents a number. As we have infinite number of points on the line, we have infinite number of numbers. In between these 2 points also, like 1 and 2 also, we have infinite number of points, so that we can have infinite number of numbers in between 2. Okay, we can't use directly the word infinite in unless, otherwise we may use countless numbers. Okay, and then to represent root 2 on the number line, represent root 2 on the number line. First we have to draw the number line. After drawing the number line, mention 0, origin. So from the origin we have to take 1 unit distance. 1 unit distance means 1, and Perpendicularly we have to take 1 unit distance. How will you take perpendicularly 1 unit distance? Using set square. Remember set square? This like one. I think I'm having it. Do you know that set square, right? See, we have these two set squares. One is like this and the other is like this. Which set square will you use? Right side or left side? Right side. We are using this set square only to make sure whether it is 90 degree or not. So you just place it along the longer side in the sense this L shaped side, no? That you paste it along, keep it along this side 0. So 1 unit you have to mark it first. After marking 1 unit only, in that point we have to keep it, and we have to mark 1 unit distance here. As I am drawing bigger, I am taking this as 1 unit. So this set square makes sure that that line is perpendicular. Okay. So after that perpendicular distance, see, connect the points. This is A and this is B. We connect these two. So by right angle triangle, Pythagoras theorem. 1 unit now this length is root 2 units. Okay. Now how do we mark this root 2 on the number line? We will take a compass. You know compass, right? This like we will take our compass, and using this compass we have to measure this. Using this compass we have to measure this length. After measuring, that has to be intersect with the line, keeping O as the origin for the circle. Likewise we have to draw. So the point where it intersects, that is the place of the number root 2. Okay, clear? So where it will intersect means exactly in between 1 and 2. That too somewhat nearer to, somewhat in between 1 and 2, right in the middle. Okay, not somewhat in between, not exactly. Okay, next represent root 3 on the number line. How we can do? Can anyone remember? Root 2 as the base, and then again we have to draw a perpendicular line. See, place the set square again along the line root 2. Do you know how to paste it? See, placed it. So along the line root 2 we have to place it, and then we have to take another 1 unit distance. As I am drawing bigger, that is why I am taking like this. But when you draw, you take exactly 1 unit, or else 2 centimeter as 1 unit also you can take, not a problem. Okay. So again here 1 unit distance we have to, and then the length of OC is how much? Root 3. How to mark this root 3 on the number line? This like we can place our compass and intersect. Where it will intersect? Exactly near to this 2, because root 3 value is 1.73. Okay. So that is the place of root 3. So we can say this is D, this is D. The points D and E represents root 2 and root 3. Like this you can write. Any doubts in this? Now root 5. Any guesses? Again we have to continue from this. Again perpendicular distance. Yes sir. Simply I am saying, man. See, again 1 unit. This is again root 4. Root 4 nothing but 2. Exactly that will intersect 2. And then again we will take 1 unit, intersect with, that is root 5. Then that intersects with the other one. Okay, that is between 2 and 3. Okay. Root 5 directly also we can draw. How we can draw? See, 0. We can take 2 units. 2 units here, and then perpendicularly 1 unit we can take. When you take perpendicularly 1 unit now, here 1, here 2 will be there. Okay. And then perpendicularly 1 unit now. When you connect this, what is this value? Root of 2 square plus 1. That is nothing but root 5. Then again this length we can mention, we can mark it. Both are same. Either way we can do. Okay. So this like what we are drawing is called a spiral, square root spiral. Sorry, square root spiral. How do they call it? Yes, square root spiral. That square root spiral we have to draw for the exercise question. Okay. Any doubts in this? How to draw these things? The second exercise is about only this. Okay. Any doubts? Okay. Next, the third one, decimal expansion. Okay. So whenever a division happens, there are two type of decimal expansion will come. One is a terminating decimal, other is a non-terminating decimal. So there are two scenarios in which a remainder is 0. Remainder 0. Here remainder not equal to 0. So when remainder 0, everything over, no problem at all. But suppose when you divide some number, the remainder is not 0. Why I am speaking of division here? Because of the form P by Q. As I mentioned earlier, this represents quotient Q. So this quotient may be a whole number. Like if remainder is 0, we will have a whole number. Otherwise, we may have a two type of different decimal expansion. One is terminating decimal expansion. Other is non-terminating decimal expansion. Okay. So in the terminating decimal expansion, no problem. It is terminating, it is over. But the non-terminating decimal expansion, we have two different types. One is repeating and non-repeating. Okay. See, I think we have drawn this type of chart in your classroom while we have studying this. Did we or not? Now, take some examples. For example, 35 by 7. When you divide it, what you may get? 5. Remainder 0. No more decimal expansion. When remainder is not equals 0, take 23 by 2. What is the decimal expansion? When you divide it, how will you divide? You remember? This like 23 divided with 2. 1 2s are 2. And then 0, 3. Again 1 2s are 2. Remainder 1. Decimal point 0. 5 2s are 10. So 11.5. What kind of decimal expansion it is? Terminating. Okay. Likewise, terminating, non-repeating, not a problem. Terminating means terminating also repeating, non-repeating will come? No. Terminating, there is no repeating, non-repeating. Okay. Non-terminating only, repeating, non-repeating. So, non-terminating, take for example 10 by 3. What is 10 by 3? .33333 like it is going on. When you divide like this. So, in that case, we will be representing 3.3 bar. Okay. And then non-repeating. Say some example. Say this non-terminating and non-repeating. For example, take pi. Value of pi is 3.1428 something it is going. Shall we say 22 by 7 as non-terminating, non-repeating? Shall we say? Because pi is equal to 22 by 7 now. No, we can't say. Because pi only approximates to 22 by 7. Not equal to 22 by 7. The approximate value. Pi value also starts with the 3.14. This 22 by 7 also starts with 3.14. But on the other hand, this 22 by 7 is a repeating decimal. You know, plot twist. 22 by 7 is a repeating decimal. Okay. So we are approximating these first 3 digits to pi. That is why we are using 22 by 7 all the time. Got it? Any doubts, confusion, clarifications? Okay. Now the conversion. Converting these things. Converting fractions into decimal. That is easier thing. Fractions into decimal means like rational number. As we discussed earlier, 10 by 3. Directly we can divide like this. And 2 by 7. Directly we can divide like this, man. What we may get? 0.20. 2 times 14 and then 6, 60. 8 times 8 7s are 56 and then 4, 0. 5 times 35 and then 5, 0. 7 times 49 and then 1, 0. 1 time 7 and then 3, 0. 4 times 28 and then 2. Again the cycle repeats. 2, 8, 5, 7, 1, 4. Okay. So we may put one bar on this. So fraction, rational number to decimal conversion like that. Okay. So when you notice this kind of decimal conversion, it is notable that whenever this divisor is, shall I erase everything? Whenever the divisor is not product of 2 or 5 or both 2 and 5, you will be having a non-terminating decimal. Okay. So to have a terminating decimal, the denominator should be in the form 2 power m into 5 power n. Only this form. Take for example, you see 3 by 12. If I divide means, will I get a terminating decimal or non-terminating decimal? Simplify this, you may get 1 by 4. So that is 1 by 2 square. Yes, it is in this form. But sir, 5 is not there. Not a problem. This n will become 0. Okay. So yes, it is a terminating decimal. Without even actually doing the division, we can say whether it is a terminating or non-terminating. We can't say the answer directly, but we can say whether it is terminating or non-terminating. Okay. Now 120 by 343. Will it be a terminating decimal or non-terminating decimal? Can you say? Why is it so? Okay, 2 power m and 5 power m. Okay, either only 2 should be there or only 5 should be there, or else product of these two powers should be there. Either way, we will be having only non-terminating decimals. Got it? So that is the thing about this conversion. And then the other conversion, like the terminating, non-terminating to rational number. See, terminating decimal to rational number is very easy. Take for example 0.125. Terminating to rational number. The terminating to rational number 0.125. Simply remove all the decimals. Put 1 divided by. See, we have 3 decimals here. So 1 followed by 3 zeros. Okay. That's all. This is the rational number. And then simplest form of a rational number, What is the simplest form of rational number that we have studied in 8th class? These numerator and denominator should not have a common factor other than 1. Are they having any common factor other than 1? Yes, they are. It is 5. Okay. I am going to divide it by 25. 25 means like I am getting 5. And then here 25 means this one 440. Correct? 4 times. Then again 1 by 8. Got it? That is how we can convert this terminating into rational number. Here, the same way, non-terminating decimal into fractions. See, non-terminating and non-repeating. Meaning what? It is an irrational number. Non-terminating and non-repeating means what? It is irrational number. It can't be converted into the form of p by q. That is why we are calling it as irrational number. Okay. We have seen two different definitions for irrational number. One is it cannot be represented in the form of p by q, and the other is it will be having non-terminating and non-recurring decimal expansion. Okay. Now, this non-terminating repeating, will it be a rational number? Will it be a rational number, man? Say, man. Non-terminating, non-repeating means irrational number. We can't convert that into the form of p by q. But non-terminating repeating means we can convert that into the form of p by q. Okay. See, for example, this 3.3 bar alone we will take. Whatever the number given, we have to take it as x. Let x is equals to 3.333 like we will take. And then, very importantly, how many decimal parts are repeating? Only one. We have to multiply this with 10. So, this one multiplied with 10 will be having 10x. Then what we are having? 33.333 like we may have. Okay. So, that is equation 2. Simply 2 minus 1 will do. Why I am doing 2 minus 1? Big number minus small number. And then 33.33333. Oh, no. 10x equals 33.3333. It is there, no? Minus 1. So, minus x. Here 03.33333. Like we have to subtract. When you subtract these two, here 0.333 na 0.00000 only will come. So, this part fully cancelled. Now, 33 minus 3, how much? 30. Then, what we are having is 10x minus x. 10x minus x, it is 9x. So, we will be having 9x is equals 30 and then x is equals 30 by 9. So, 30 by 9, is this the simplest form of the rational number? 10 by 2. Got it? This is the process of how we are working out. Okay. Suppose some numbers are not repeating. In that case, what we can do? Shall I erase everything? Shall I erase everything? Suppose some numbers are not repeating. for example 0.235 bar, meaning what? Only 35 is repeating and this 2 is not repeating. So in that case we will be taking x is equal to 0.2, this one 35, 35, 35. This block of numbers always repeats. Whatever comes under the bar, that block of numbers always repeats. And then here there are new method. What does that mean? First we have to bring that non-repeating decimal to the front. Okay. How will you bring it? How many digits are there? Only one digit. That has to come front. What number we have to multiply? Answer. Unmute yourself and say 10x. So 10x is equals through 0.353535 and so on it goes. That is our equation 1. Previously, initially whatever given itself we have taken it as x as equation 1. Here this non-repeating number brought to front, that number alone we are taking it as 1. And then usual process, one block of repeating decimal should come front. How many decimals are repeating? 2 decimals. So we have to multiply what? 100. So multiply 100 with what? This equation or this equation? Second one. So equation 1 into 100. What you may get is 1000x is equals 235.353535 and so on. That is our equation 2. I hope you have got it. First we have to bring that non-repeating numbers to the front and then we have to go for the repeating decimal, that too for that particular block. Okay. So now as usual equation 2 minus 1. So what is the first equation? 10x and we have 2.353535 and so on. We have to subtract all this. When you subtract all this, 1000 minus 10, 990x. And here 235 minus 2, 233. This 35, 35, 31, 3 minus 3, 0, 5 minus 5, 0, 3 minus 3, 0, 5 minus 5, 0, 3 minus 3, 0, 5 minus 3, 0. Likewise, you can say your life long, it won't be ending, is it? So, x is equals 233 by 990. That is the rational number expansion, P by Q form of this particular number. Okay. I have given one shortcut also, you remember? Where to use that shortcut, when to use that shortcut. In case of MCQ 7. What was that shortcut as actually? See, simply the given number without decimal point and bar minus the block of non-repeating decimals, non-repeating numbers, not only decimals, all over the number, what are all the numbers are non-repeating, that number, and divided by, we have to put nines. How many nines? As many repeating decimals. And after that zeros. How many zeros you have to put? As many as non-repeating decimal points, not all the numbers. Okay. So whenever we speak of numerator, throw the number. Whenever comes to denominator, after the decimal point, only counts. Now take this example. So the given number without decimal, without bar, what is that number? 235, is it? I didn't put decimal, I didn't put bar. Minus Non-repeating part. Which part is not repeating? 2 alone. Actually, it is 0, 2. 0 don't have any resemblance, and that's why I am not putting. We have to put full number right from the beginning, non-repeating until the repeating. Okay. Clear? So, denominator has 9s. How many 9s? As many as repeating decimals. How many decimals are repeating? 2. So, 2, 9. Zeros. As many as non-repeating decimals alone. 1 0. So, answer saves time. Okay. Can you say what is the P by Q form of 12.235 bar? Twelve point would be tough. Make it as 1 point. Come on, use the shortcut and say. One, two, two, three. See, actually the number without decimal, without bar, 1, 2, 3, 5 minus the non-repeating part alone, 12 divided by as many as 9s. So it is 9, 9. Only decimal part we have to take into count, denominator now. Okay. And then this one, 0. 1235 minus 12, how much? 1223 by 990 is the answer. Suppose this can be divisible by 2 means 2 or 3, whatever the number. You have to simplify that. Got it? That is it. So that is how we have to do the conversion. Okay. Hope you got it. So let us everything. Now, finding irrational number between two given number. How will you find irrational number between two given number? Rational na easily you can find. Irrational means, see, take for example 1 and 2. Find 3 irrational numbers. How will you find irrational numbers? Means, say, this number 1, that number 2. In between whatever comes like 1.2, which shall we say? But 1.2 is irrational number. What makes a decimal number irrational is, it should be non-terminating, also non-repeating. Okay. So, we may crack this or fool this by following a pattern so that we make sure it is non-repeating. Okay. Just to make sure it is non-repeating, we are doing this. What we are doing? See, 2 is there. 2 0, 2 00, 2 000, and so on it goes. But sir, the number repeats, no. No. You can't particularly say any particular block of number is repeating. One may say that you can write like 1.2468, 5743, 5434, what is that? I forgot. Likewise you can write. Okay. Which will you accept as a irrational number? This one or this one? First one. First one is purely irrational. This guy we don't know. See, he is having all these 1, 2, 3, 4, get on the dance floor, everything he is having. At last, there may be a chance that a particular block of number repeats. Suppose a 3, 5 repeats after this. Who knows? Is there a chance or not? Can you say here any particular block of number repeats after this? So, no. So, this we should not write, only this. Is it only necessary to do like this? Even we can write 1.52, 522, 5222 and so on. Got it? That like we can find as many as irrational numbers. Okay sir, 1 and 2, not a problem. What if we are having 3 by 5 and 4 by 3? 4 by 3, yeah. We should divide this and find the decimal expansion. So this decimal expansion 0.6. This one decimal expansion 0.9 something will come. Oh sorry, 1.333 will come. Is it or not, right? Then between 0.6 and 1.3, this 0.7 lies in between these two, right? So 70, 700, 7000 and so on it goes. Or else 1.31, 311, 3111 and so on it goes. Okay. 1.2 also we can take. 1.4 shall we take? Hey, 1.4 we can write, see 1.41, 411, 4111, we are having irrational number. Why? Because that exceeds the number. Or 0.5 shall we take the other side? No, we can't, because that again exceeds. Okay, clear? And suppose they gave root 2 and root 3 dakana. We should find and no, we should say root 2 value how much? 1.414, root 3 value 1.732. So between 1.4 and 1.5 we have, 1.7 we have infinite number of numbers. We can start like 1.51, 511, 5111 or else 1.60, 611, 622. Even we can start with 1.72, 71. Whatever number we can wish, we can start. Okay, but that has to be follow this pattern. Okay, got it? Okay, man. Next, operations on real numbers. So this operation on real number is quite simple. In that there are some different type of question. As you have to memorize all these values of irrational numbers. Root 5. Sweating or sleeping? This is 2.24 Ada. What is root 5 value? And then pi is 3.1428 something it will come. These are all the values. See, we need to check whether this 7 root 5 is a rational or irrational number. How will you check whether it is rational or irrational number? See, 7 into, what is the decimal expansion of root 5? 2.24. What is the decimal expansion of root 5? 2.24. After that, 236 and so on. So this is non-terminating, non-repeating decimal. When you multiply 7 with this, again we will get what? We will get non-terminating, non-repeating decimal. So therefore, 7 root 5 is irrational number. Got it? The same way for everything. But what will you do for 7 root 5? 7 by root 5? 7 by 2.236 and so on. Here how will you manage to say? In this time, for this time, we have to do rationalizing the denominator. How will you rationalize the denominator? Means the same value, whatever in the denominator, the irrational number, we have to change the sign. Suppose sum of the number is there, means we have to change the sign. Single number, same number you can multiply. So root 5 has to be multiplied. 7 root 5 by 5. As this is irrational number, by 5 also it is irrational again. Okay, got it? That is why we have to prove. For that, these values we have to memorize, no other go. And then a rational into rational number, what we may get? Rational plus, minus, add, subtract, multiply or divide, whatever you do. Oh, not division, you can't say. Division, we may get irrational also. No, not possible. So, rational in whatever you do, you may get is only rational. And rational added, subtracted or multiplied or divided with irrational is what? Always irrational. And irrational addition or subtraction or product or division with irrational, it is maybe rational or irrational. Why? Because when you add or subtract or multiply or any irrational number with rational number, 2 root 3, 2 plus root 3, all the things are irrational by nature. We have proved this. Okay. Rational with rational also again it will be rational only. Because P by Q form we can write, division also. P by Q form we can write, whenever you can write P by Q form, either we may get terminating decimal or non-terminating decimal. That could be non-repeating. See, non-repeating we can't get. What we are getting is repeating only we may get. Okay. Clear? There is no chance of getting this non-terminating, non-repeating. Why? Because if you are getting non-terminating, non-repeating decimal means, first of all, it could not be written in the form of P by Q itself. That is why I included division also here. Are you getting what I am saying? Yes, good. Likewise, rational with irrational also always irrational only. But irrational with irrational we can't say like that. Sometimes you see 2 minus root 3 is irrational, 2 plus root 3 is irrational, why 2 plus 5 plus root 3 is irrational. When you add these two, what you will get? 7. Is this rational or irrational? When you subtract these two, what you will get? Minus 2 root 3 you may get. That is irrational. We can't predict whether it is rational or irrational. Got it? Okay. Any doubts? Okay. Next, representing any irrational number on the number line. Are you writing this? Noting this down? You have already written this in your classwork, is it? Okay. How will you represent any irrational number on the number line first? Whatever it is, this root x on number line, simply we have to draw x units length. After that, increase that line segment for 1 units. Okay. After that, we have to draw perpendicular bisector for this AC. AC in a full number line. So, when you draw perpendicular bisector, what you may get? How will you draw that first? By taking your compass, measuring more than half of this line AC, not AB. Okay, more than half of this line, we can draw upwards one arc and then keep the compass again in the point C. Here one arc we can draw. Likewise, below also, keeping the point at A. Here one arc, keeping the pointer at C. This one arc, and these two can be connected. And this point in which this is intersecting, that is the midpoint. Why we have found this midpoint? Using this midpoint, we have to draw a semicircle. Okay, that semicircle should be exactly intersect with this point C. So, after that, from this point B, we have to keep the set square. Keep the set square and draw a perpendicular line like this. Now this length is our root x length. Okay. Now extend this line further. Measure this line using the compass. Intersect this line. That is the point E where this root x lies. And after that we have to mark this point B as 0, C as 1 and E as root x. So for 9.3, 5.2, whatever number they give, this is the procedure. Okay. Any doubts in this process? You know that, right? And then next, properties, exponents and powers. Rationalization denominator we already discussed, right? For example, 1 by 7 minus root 2. Why 1 by 5 by? How will you rationalize the denominator? 7 plus root 2. See here also 7 plus root 2. 7 plus root 2 by 7 plus root 2. So here we have to use a square minus b square, that formula. A plus b into a minus b, that form. Okay, 49 minus 2. So 5 plus 7 root 2. 49 minus 2. So 35 plus 5 root 2 divided by 47. Got it? Denominator is rationalized. This type of question they may ask. And then exponents and powers, as you know. For exponents and powers, I already discussed those things in this channel itself. Check out the playlist. In that basic mathematics, I have discussed about exponents and powers. The same concept we are using in grade 9 also. Okay. You just kindly do check out if you are looking for this video for exponents and powers. Okay. Thank you so much. Again, I am telling, in the playlist section, basic mathematics, exponents and powers is there. Okay. Check out that, so that we'll have a overview of this number systems chapter. Okay, all the best with your exams. Score more. Do let me know if you wish to. Okay, all the best.